Section 2. Mastering File and Directory Access Control, DAC. This section will talk about protecting sensitive files and directories by setting proper permissions and ownership, and by using extended attributes XOTR. You will also see how to avoid security-related problems with set user ID, SUID, and set group ID, SGID. This section contains the following chapters. Chapter 8, Mastering Discretionary Access Control. Chapter 9, Access Control List and Shared Directory Management. 8. Mastering Discretionary Access Control. Discretionary Access Control, DAC, really just means that each user has the ability to control who can get into their stuff. If I wanted to open my home directory so that every other user on the system can get into it, I could do that. Having done so, I could then control who can access each specific file. In the next chapter, we'll use our DAC skills to manage shared directories where members of a group might need different levels of access to the files within. At this point in your Linux career, you'll likely know the basics of controlling access by setting file and directory permissions. In this chapter, we'll review the basics and then we'll look at some more advanced concepts. In this chapter, we'll cover the following topics. Using chown to change the ownership of files and directories, using chmod to set permissions on files and directories, what a set user ID, SUID, and the set group ID, SGID, settings can do for us on regular files. The security implications of having the SUID and SGID permissions set on files that don't need them, how to use extended file attributes to protect sensitive files, secure system configuration files, using chown to change ownership of files and directories. Controlling access to files and directories really just boils down to ensuring that the proper users can access their own files and directories, and that each file and directory has permissions set in such a way that only authorized users can access them. The chown utility covers the first part of this equation. One unique thing about chown is that you must have pseudo privileges to use it. Even if you're working with your own files in your own directory, you can use it to change the user of a file or directory, the group that's associated with the file or directory, or both at the same time. First, let's say that you own the perm demo.txt file and that you want to change both the user and the group association to that of another user. In this case, I'll change the file ownership from me to Maggie, ls-l, sudo chown Maggie, column Maggie, perm demo.txt, ls-l. The first Maggie in Maggie column Maggie is the user to whom you want to grant ownership. The second Maggie after the column represents the group that you want the file to be associated with. Since I was changing both the user and the group to Maggie, I could have left off the second Maggie with the first Maggie followed by column, and I would have achieved the same result. Sudo chown Maggie column perm demo.txt. Just to change the group association without changing the user, just list the group name preceded by a column. Sudo chown column accounting perm demo.txt ls-l. Finally, just to change the user without changing the group, list the username without the trailing column. Sudo chown donny perm demo.txt ls-l. These commands work the same way on a directory as they do on file. However, if you also want to change the ownership and or the group association of the contents of a directory, while also making the changes on the directory itself, use the -r option, which stands for recursive. In this case, I just want to change the group for the perm demo directory to accounting. Let's see what we have to begin with. ls-ld. Now let's run the command and look at the results. Sudo chown-r column accounting perm demo ls-ld. That's all there is to chown. Next, let's change some permissions. Using chmod to set permissions on files and directories. On Unix and Linux systems, you would use the chmod utility to set permissions values on files and directories. You can set permissions for the user of the file or directory, the group that's associated with the file or directory, and more. The three basic permissions are as follows. R, this indicates a read permission. W, this indicates a write permission. X, This is the executable permission. You can apply it to any type of program file or to directories. If you apply an executable permission to a directory, authorized people will be able to cd into it. If you perform ls-l on a file, you'll see something like this. The first character of this line indicates the type of file. In this case, we can see a dash, which indicates a regular file. A regular file is pretty much every type of file that a normal user would be able to access in his or her daily routine. The next three characters are w dash, indicate that the file has read and write permissions for the user, which is the person who owns the file. Then we can see the rw dash permissions for the group and the r dash dash permissions for others. A program file would also have the executable permission set. Here we can see that the xargs program file has executable permissions set for everybody. There are two ways that you can use chmod to change permission settings, the symbolic method, the numerical method. We'll cover these methods next. Setting permissions with the symbolic method. Whenever you create a file as a normal user, by default it will have read-write permissions for the user and read permissions for the group and for others. That's because the default UMask setting of 022 causes files to be created without write permissions for the group or others. You can see what the UMask setting is like this, UMask 0022. The actual UMask setting is just 022, even though it shows up here as 0022. That extra leading 0 just indicates that this number is in octal format. Regular files will always get created without executable permissions regardless of the UMask, which is why even when you create a script or a program, you always need to set the executable permissions yourself. Here's how to do it with the symbolic method. Chmod u plus x .script.sh, chmod g plus x .script.sh, chmod o plus x .script.sh, chmod u plus x, comma, g plus x .script.sh, chmod a plus x .script.sh. The first three commands add the executable permission for the user, the group, and others. The fourth command adds executable permissions for both the user and the group, whilst the last command adds executable permissions for everybody, A for all. You can also remove the executable permissions by replacing plus with minus. Finally, you can also add or remove the read or write permissions as appropriate. While this method can be handy at times, it also has a bit of flaw. That is, you can only add permissions to what's already there or remove permissions from what's already there. If you need to ensure that all of the permissions for a particular file get set to a certain value, the symbolic method can be a bit unwieldy. And for shell scripting, forget about it. In a shell script, you need to add all kinds of extra code just to determine which permissions have already been set. A numerical method can vastly simplify things forward. Setting permissions with the numerical method. With the numerical method, you'll use an octal value to represent the permission settings on a file or directory. For the R, W, and X permissions, you assign the numerical values 4, 2, and 1 respectively. You would do this for the user, group, and others positions, and then add them all up to the permissions value for the file or directory. So if you have all the permissions set for everybody, the file or directory will have a value of 777. If I were to create a shell script file, by default it will have the standard 664 permissions, meaning read and write for the user and group, and read only for others. If you create a file with root privileges, either with sudo or from the root user command prompt, you'll see that the default permission setting is the more restrictive 644. Let's say that I want to make this script executable, but I want to be the only person in the whole world who can do anything with it. To do this, I could do the following: chmod 700 .script.sh, ls-l.script.sh. With this one simple command, I removed all permissions from the group and from others and set the executable permission for myself. This is the sort of thing that makes the numerical method so handy for writing shell scripts. Once you've been working with the numerical method for a while, looking at the file and figuring out its numerical permissions value will become second nature. In the meantime, you can use stat with the -c %a option to show you the values. This can be done like so: stat-c %a yum-list.txt 664, stat-c %a .script.sh 700, stat-c %A, etc. fs tab 644. If you want to view the numerical permissions of all the files at once, do this. stat-c %n %a star. Here you can see the wildcat star at the end of the command indicating that you want to view the settings for all the files. %n indicates that you want to view the file names along with the permission settings. Since we're using 2-c options, we have to enclose both of the options within a pair of single quotes. The only slight catch here is that this output doesn't show which of these items are files and which are directories. However, since directories require executable permissions so that people can cd into them, we can guess that procvar is probably a directory. So to be sure though, just use the ls-l like so. ls-l. Now let's move on to a couple of very special permission settings. Using suid and SGID in regular files. When a regular file has its suid permission set, whomever accesses the file will have the same privileges as the user of the file. To demo this, let's say that Maggie, a regular unprivileged user, wants to change her own password. Since it's her own password, she would just use the one-word password command without using sudo. Passwords. Change the password, a person has to make changes to the etc shadow file. When I send to us on all Linux machines, the shadow file's permissions look like this, ls-l. On an Ubuntu machine, they look like this, ls-l shadow. Either way, the permission settings don't allow Maggie to directly modify the shadow file. However, by changing her password, she is able to modify the shadow file. So what's going on? To answer this, let's go into the usr bin directory and look at the permission settings for the passwd executable file. cd usr bin ls-l password. For the user permissions, you will see RWS instead of RWX. The S indicates that this file has the suid permission set. Since the file belongs to the root user, anyone who accesses this file has the same privileges as the root user. The fact that we see a lowercase s means that the file also has the executable permission set for the root user. Since the root user is allowed to modify the shadow file, whoever uses this password utility to change his or her own password can also modify the shadow file. A file with the SGID permission set has an S in the executable position for the group. ls-l write. The write utility, which is associated with the TTY group, allows the user to send messages to other users via the command line consoles. Having TTY group privileges allows users to do this. The security implications of the suid and SGID permissions. As useful as it may be to have suid or SGID permissions on your executable files, we should consider it as just a necessary evil. While having suid or SGID set on certain operating system files is essential for the operation of your Linux system, it becomes a security risk when users set suid or SGID on other files. The problem is that if intruders find an executable file that belongs to the root user and has the suid bit set, they can use that to exploit the system. Before they leave, they might leave behind their own root-owned file with a suid set, which will allow them to easily gain entry to the system the next time they encounter it. If the intruder's suid file isn't found, the intruder will still have access even if the original problem has been fixed. The numerical value for suid is 4000 and for SGID is 2000. To set suid on a file, you could just add 4000 to whichever permissions value that you would set otherwise. For example, if you have a file with a permissions value of 755, you set suid by changing the permissions value to 4755. This would give you read, write, execute access for the user, read, execute for the group, and read, execute for others, with the suid bit added on, finding spurious suid or SGID files. One quick security trick is to run the find command to take inventory of the suid and SGID files on your system. You can also save the output to text files so that you can verify whenever anything has been added. Since you ran the command, your command will look something like this: sudo find /type f perm 4000 o perm 2000 greater than sign suid SGID files.txt. Use the breakdown /. We're searching through the entire file system. Since some directories are only accessible to someone with root privileges, we need to use sudo. Type F. This means that we're searching for regular files, which includes acceptable program files and shell scripts. Perm 4000. We're searching for files with the 4000 or suite permission bit set. /O, the OR operator. Perm 2000. We're searching for files with the 2000 or SGID permission bit set. Greater than sign. Here we're redirecting the output into the suite SGID files txt text file with the greater than operator. Note that the two perm items need to be combined into a term that's enclosed in a pair of parentheses. To prevent the bash shell from interpreting the parentheses characters incorrectly, we need to skip each one with a backslash. We also need to place a blank space between the first parentheses character and the first perm, and another between 2000 and the last backslash. Also, the AND operating between type F and the perm term is used to be here, is understood to be here, even without inserting the A. The text file that you create should look something like this. Optionally, if you want to see details about which files are suite and which are SGID, you can add the -ls option. Sudo find root type F perm 4000 or perm 2000 ls greater than sign suite SGID files of txt. Okay, now you're saying, hey, Doggy, this is just too much to type, and I hear you. Fortunately, there's a shorthand equivalent of this. Since 4000 plus 2000 equals 6000, we can create a single expression that will match either the suite 4000 or the SGID 2000 value like this. Sudo find / type F perm 6000 ls greater than sign suite SGID files of txt. That 6000 in this command means that we're looking for either the 4000 or the 2000 value. For our purposes, these are the only two add-ins that can combine to make 6000. In all the references, you might see plus 6000 instead of /6000. You see the plus sign for this has been deprecated and no longer works. Now let's say that Maggie, for whatever reason, decides to set the suite bit on a shell script file in their home directory. Chmod 4755 bad script.sh ls the shell. Run the find command again, saving the output to a different text file. Then perform a diff operation on the two files to see what changed. Diff suite SGD files txt, suite SGD files 2.txt. The only difference is the addition of Maggie's shell script file. Hands-on lab searching for suite and SGID files. You can't perform this lab on either of your virtual machines. You save the output of the find command to a text file. Let's get started. Searching through the entire file system for all the files that have either suite or SGID set before saving the output to a text file. Sudo find / type F perm 6000 ls greater than sign suite SGID files of txt. Log into any other user account that you have on the system and create a dummy shell script file. Then set the suite permission on that file and log back out and back into your own user account. su / this is our user account. Touch some shell script.sh, chmods 4755 some shell script.sh, ls-l, some shell script.sh, exit. Run the find command again, saving the output to a different text file. Sudo find / type F perm 6000 ls greater than sign suite SGID files 2.txt. Be the difference between the two files. Diff suite SGID files txt, suite SGID files 2.txt. That's the end of the lab. Congratulations. Preventing suite and SGID usage in a partition. As I mentioned previously, you don't want users to assign suite and SGID to files that they create because of the security risk that it presents. You can prevent suite and SGID usage on a partition by mounting it with the no suite option. So the etc fstab file entry for the lux partition that I created in the previous chapter will look like this. Dev mapper lux GUID secrets xfs no suite 00. Different Linux distributions will have different ways of setting up default partition schemes during an operating system installation. Mostly the default way of doing business is to have all the directories except for the boot directory under the /partition. If you were to set up a custom partition scheme instead, you could have the home directory in its own partition, where you could set the no suite option. Keep in mind that you don't want to set no suite for the /partition, otherwise you'll have an operating system that doesn't function properly. Using extended file attributes to protect sensitive files. Extended file attributes are another tool that can help you protect sensitive files. They won't keep intruders from accessing your files, but they can help you prevent sensitive files from being altered or deleted. There are quite a few extended attributes, but we only need to look at the ones that deal with file security. First, let's use the ls command to see which extended attributes we already have set. On a CentOS or on a Linux machine, your output would look something like this, ls. So far, I don't have any extended attributes set on any of my files. On an Ubuntu machine, the output will look more like this, ls. We won't worry about the E attribute because that only means that the partitions is formatted with the ext4 file system. CentOS and Orm Linux don't have the attribute set because the partitions are formatted with the XFS file system. The two attributes I will look at in this section are as follows. You can append text to the end of a file that has this attribute, but you can't overwrite it. Only someone with proper pseudo privileges can set or delete this attribute. This makes a file immutable, and only someone with proper pseudo privileges can set or delete it. Files with this attribute can be deleted or changed in any way. It's also not possible to create hard links to files that have this attribute. To set or delete attributes, you need to use the chattribute command. You can set more than one attribute on a file, but only when it makes sense. For example, you wouldn't set both the A and I attributes in the same file because the I would override the A. Let's start by creating the perm.demo.txt file, which contains the following text. This is Donnie's sensitive file that he doesn't want to have overwritten. Now let's go ahead and set the attribute, setting the A attribute. Now I'll set the A attribute, sudo chattr plus A perm.demo.txt. Use plus to add an attribute and minus to delete it. Also, it doesn't matter that the file belongs to me and is my own home directory. I still need pseudo privileges to add or delete this attribute. Now let's see what happens when I try to overwrite this file. Echo, I want to overwrite this file greater than sign perm.demo.txt. Operation not permitted. With or without pseudo privileges, I can't overwrite it. So how about if I try to append something to it? Okay, I want to append this to the end of the file, greater than sign, perm.demo.txt. There's no error message this time. Let's see what happens. This is only sensitive file that he doesn't seem to want, that he doesn't want to have overwritten. I want to append this to the end of the file. In addition to not being able to overwrite the file, I'm also unable to delete it. rm perm.demo.txt cannot remove demo.txt, operation not permitted. So the A works, however, I've decided that I no longer want this attribute to be set, so I'll remove it. Sudo chattr-a perm.demo.txt ls attribute perm.demo.txt. Setting the I attribute. When a file has the I attribute set, the only thing you can do with it is view its contents. You can't change it, move it, delete it, rename it, or create hard links to it. Let's test this with the perm.demo.txt file, sudo chart plus I perm.demo.txt ls attribute perm.demo.txt. Now for the fun part. Sudo echo, I want to override this file greater than sign perm.demo.txt. Permission denied. Echo, I want to append this to the end of the file greater than sign perm.demo.txt. Permission denied. Sudo echo, I want to append this to the end of the file greater than sign perm.demo.txt. Permission denied. Remove -f perm.demo.txt cannot remove the perm.demo.txt, permission not permitted. Sudo remove -s perm.demo.txt. Remove cannot remove perm.demo.txt, operation not permitted. Sudo remove -f perm.demo.txt. There are a few more commands that I could try, but you get the idea. To remove the I attribute, to do this, sudo chattr-i perm.demo.txt. ls attribute perm.demo.txt. Hands-on lab setting security-related extended file attributes. For this lab, you'll need to create a perm.demo.txt file with some text of your choice. You'll set the I and A attributes to view the results. Let's get started. Using your preferred text editor, create a perm.demo.txt file with a line of text. View the extended attributes on the file. ls attr perm_txt, add the a attribute sudo attr plus a perm_txt ls attr perm_txt. Try to overwrite and delete the file. Echo, I want to overwrite this file. It's greater than sign perm_txt. Sudo echo, I want to overwrite this file. It's greater than sign perm_txt. Remove perm_txt sudo rm perm_txt. Now append something to the files. Echo, I want to append this line to the end of the file, greater than sign perm_txt. Remove the a attribute and add the I attribute. Sudo attr -a perm_txt ls attr perm_txt sudo attr plus I perm_txt ls attr perm_txt. Repeat step 4. Additionally, try to change the file name and create a hard link to the file. Move perm_txt some file.txt, sudo move perm_txt some file.txt, ln perm_txt some file.txt, sudo ln perm_txt some file.txt. Now try to create a symbolic link to the files. ln/s perm_txt some file.txt. Note that the I attribute won't let you create hard links to a file, but it will let you create symbolic links. That's the end of the lab. Congratulations. Securing system configuration files. If you look at the configuration files for any given the Linux distro, you'll see that most of them belong to either the root user or to a specified system user. You'll also see that most of these files have read and write privileges for the respective owners and read privileges to everyone else. This means that everybody and his brother can read most Linux system configuration files. Take, for example, this Apache web server configuration file, cd etc httpd conf pwd etc httpd conf ls/l. With that R in the author's possession, everybody who logs in, regardless of their privilege level, can view the Apache configuration. So is this a big deal? It really depends on upon your circumstances. Some configuration files, especially ones for certain PHP-based content management systems, CMS, on a web server, can contain plain text passwords that the CMS must be able to access. In these cases, it's quite obvious that you need to restrict access to these configuration files. But what about other configuration files that don't contain sensitive passwords? For servers that only a chosen few administrators can access, this isn't such a big deal. But what about servers that normal non-administrative users can access remotely via secure shell? If they don't have any sudo privileges, they can't edit any configuration files, but they can view them to see how your server has been configured. If they see how things are configured, would that help them in their efforts to compromise the system should they choose to do so? I have to confess, this is something that I hadn't thought much about until recently, when I became a Linux consultant for a company that specializes in the security of Internet of Things devices. With IoT devices, you have a bit more to worry about than you do with normal servers. Normal servers are protected with a high degree of physical security, while IoT devices often have little to no physical security. You could go your entire IT career without actually seeing a server, unless you're one of the few who have been authorized to enter the inner sanctum of the server room. Conversely, IoT devices are generally out in the open. The IoT security company that I work with has a set of guidelines that help harden IoT devices against compromise and attack. One of them is to ensure that all the configuration files on the devices are set with the 600 permission setting. This would mean that only the owner of the file, generally either the root user or the system account, can read them. However, there are a lot of configuration files and you need an easy way to change the settings. You can do that with our trusty friends define utility. Is how you can do this. Sudo find /iname star.conf exec chmod 600 curly bracelets reverse / semicolon. Here's the breakdown. Sudo find /iname star.conf. This does exactly what you expect it to do. It performs a case insensitive -iname search throughout the entire root file system for all the files with the .com file name extension. All the file name extensions you might look for include .ini and .cfg. Also, because find is inherently recursive, you don't have to provide an option switch to get it to search through all the lower level directories. Exec. This is what performs the magic. It automatically executes the following command on each file that find finds without prompting the user. If you rather answer yes or no for each file that find finds, use OK instead of exec. Chmod 600 curly brackets. Chmod 600 is the command that we want to perform, as find finds each file its file name is placed within the pair of curly brackets. Every exec clause has to end with a semicolon. To prevent the bash shell from interpreting the semicolon incorrectly, we have to escape it with a backslash. If you decide to do this, test things thoroughly to ensure that you haven't broken anything. Most things work just fine with their configuration file set to a 600 permission setting, but some don't. I've just performed this command on one of my virtual machines. Let's see what happens when I try to ping an internet site. Ping civilpolitics.com. This looks bad, but the explanation is simple. It's just that in order to have internet access, the machine has to be able to find a DNS server. DNS server information can be found in the etc.result.conf file, from which I've just removed read permissions for others. Without the read permissions for others, only someone with root user privileges can access the internet. So unless you want to restrict internet access to users with root or sort of privileges, you need to change the result.conf permission setting back to 644. ls-l sudo chmod 644 result.conf. Okay, let's try this again. Ping civicsandpolitics.com. That looks much better. Now let's reboot the machine. When you do, you get this output. Figure 8.1, wrong permission setting on the locally.com file. So I also need to set the etc.locally.com file back to the 644 permission for the machine to boot properly. As I mentioned previously, be sure to test everything if you choose to set more restricted permissions on your configuration files. As I've already stated, you might not always find it necessary to change the permissions of your configuration files from their default settings, but if you ever do find it necessary, you now know how to do it. You definitely want to make friends with the find utility. It's useful both on the command line and within shell script, and it's extremely flexible. The command page for it is very well written, and you can learn just about everything you need to know about find from it. To see it, just use the man find command. Once you get used to find, you'll never want to use any of those fancy GUI type search utilities again. Okay, I think that this wraps things up for this chapter. Summary. In this chapter, we reviewed the basics of setting ownership and permissions for files and directories. Then we covered what suite and SGID can do for us when they're used properly, as well as the risk of setting them on our own executable files. After looking at the two extended file attributes that deal with file security, we wrapped things up with the handy time-saving trick for removing bold readable permissions from your system configuration files. In the next chapter, we'll extend what we learned here to more advanced file and directory access techniques. I'll see you there. Questions? Which of the following partition mount options would prevent setting the suite and SGID permissions on files? No SGID, no exec, no suite, no user. Which of the following represents a file with read and write permissions for the user and the group and read-only permissions for others? 775, 554, 660, 664. You want to change the ownership and group association of the sumfile.txt file to Maggie. Which of the following commands would do that? Sudo chown Maggie sumfile.txt, sudo chown column Maggie sumfile.txt, sudo chown Maggie column sumfile.txt, sudo chown column Maggie column sumfile.txt. Which of the following is the numerical value for the SGID permission? 6,000, 2,000, 4,000, 1,000. Which command would you use to view the extended attributes of a file? ls-attr, ls-a, ls-l, attr. Which of the following commands would search through the entire file system for regular files that have either the suite or the SGID permission set? Sudo find /type f perm 6000, sudo find /perm 4000 o perm 2000 sudo find /type f perm 6000, sudo find /type r perm 6000. Which of the following statements is true? Using the symbolic methods to set permissions is the best method for all cases. Using the symbolic method to set permissions is the best method to use in shell scripting. Using the numeric method to set permissions is the best method to use in shell scripting. It doesn't matter which method you use to set permissions. Which of the following commands would set the suite permission on a file that has read, write, execute permissions for the user and group and read, execute permissions for others? Sudo chmod 2775 some file, sudo chown 2775 some file, sudo chmod 1775 is on file, sudo chmod 4775 is on file. Which of the following functions is served by setting the suid permission on an executable file? It allows any user to use that file. It prevents accidental erasure of the file. It allows others to have the same privileges as the user of the file. It allows others to have the same privileges as the group that's associated with the file. Why shouldn't users set the suid or SGID permissions on their own regular files? It unnecessarily uses more hard drive space. It could prevent someone from deleting the files if needed. It could allow someone to alter the files. It could allow an intruder to compromise the system. Which of the following find command options allows you to automatically perform a command on each file that finds without being prompted? Exec, OK, exarch, do. For the best security, always use a 600 permission setting for every conf file on the system, true or false. Which of the following is the true statement? Prevent users from setting suid on files by mounting the / petition with the no suid option. You must have the suid permission set on certain file systems for the operating system to function properly. Executable files will never have the suid permission set. Executable files should always have the suid permission set. Which two of the following are security concerns for configuration files? With the default configuration, any normal user with command line access can edit configuration files. Certain configuration files may contain sensitive information. With a default configuration, any normal user with command line access can view configuration files. The configuration files on servers require more protection than the configuration files on IoT devices. Further reading. How you define files with suid and SGID permissions on Linux. Linux permissions, suid, sgid, and sticky bit. Linux find command, Linux and Unix file permissions, Linux file permissions. 25 simple examples of the Linux find command, 35 practical examples of the Linux find command. Answers: 1 C, 2 D, 3 C, 4 B, 5A, 6A, 7C, 8D, 9C, 10D, 11A, 12B, 13B, 14B and C.